Hello everyone, thank you for coming to my talk. I'm Andrew Goodbody, I'm a senior engineer with Linaro, and we're going to talk about U-boot testing on a Linaro Automation Appliance today. That's U-boot. I hope everyone's pretty familiar with that, and that's why you're here. Been going a while, developing rapidly. We need to test it more. Testing not only on virtual platforms, but also hardware. So, also, Linaro Automation Appliance, wonderful new piece of kit. There's a link there to find out about it. This talk is not about the automation appliance, but it is about my experience bringing up a board on it. If you want to find it, if you don't know about it, follow the link. If you do, great. Backfleet is new software to go with Lava to help using the Lava Automation Appliance. So, U-boot testing. Three main things that go on. First of all, does it build? Good start. Unit tests. These are all written in C. It can be started from the U-boot console when linked in with U-boot. And we have Python tests as well, run using PyTest. This has been the main headache. We'll come to this in a little bit. As I mentioned, we have virtual platforms. We have QEMU. We have the sandbox for testing U-boot on. The sandbox is a specific U-boot thing, a way to build U-boot, not for any particular platform, but has its own ways of testing and feeding back issues. And finally, we have hardware, real, actual hardware, which is, after all, where U-boot really needs to work. For the testing in U-boot, we have the U-boot test hooks. This is a separate repo, and is a way to make the testing that is generic in U-boot work with whatever specific platform you've got. This is, of course, most applicable to the hardware. So, starting to test a Raspberry Pi 4. Without using the Linaro Automation Appliance, Raspberry Pi 4B on my desk, hooking it up to the laptop in various ways. So, power. Got a radio-controlled power switch to control that radio power switch. Another Raspberry Pi. Simple script, and a little transmitter on the Pi to turn the switch on and off for the device under test. Board reset, USB relay, got it from eBay, a few pounds. And lo and behold, the test hooks already had examples of how to use the same USB relays. So that was all very easy. Just need to plug the USB into my laptop. Console access on the Raspberry Pi, again, another USB port. Network just to the local LAN. Setting up a TFTP server on my laptop. And I was going to use an SD-MUX to put the disk image so that was controllable. I never actually got around to setting that up, but again, another USB port. This is just one board. We need to be testing lots of different boards. We can see that I've already got 3 USB connections to my laptop, specific setup for TFTP on the laptop, as well as the power control, which, by the way, cheap power switch I was using said I can only have one at the end of any particular extension lead. So it was not going to, I might have got a second board on my desk, but after that, I couldn't do any more. So it was workable, but not scalable any further. So we want to go for the Linaro Automation Appliance. What we've got at the moment in my setup is the GitLab CI job builds the U-boot for us when you check in new code. From the build, we also extract one of the test files that is going to be needed, hello world.efi, and then the GitLab CI job writes out a Lava job. This gives us the advantage that we can embed information from the GitLab job in the Lava job, so that the Lava job is going to know how to refer back to the artifacts from GitLab. So when the Lava job runs, it's going to download the artifacts from GitLab. So again, we're dealing, back to the previous talk, it's not the same level of security, but we are still dealing with secrets that we don't want to publicize. Fortunately, both Lava and GitLab allow you to store secrets in variables that are not publicized, and we make use of this. So Lava job starts, runs a few simple tests from the U-boot console, and then it will run a Docker container. The Docker container is needed because we need to have a level of abstraction between Lava and the device under test. Lava itself always needs to have a single console connection, but PyTest also needs to have that console connection. And the way to get around this is that we have the Lava connection to the Docker container, and then the Docker container can spawn its own PyTest session, which then has the console connection to the device under test. My first issue when running the Lava job was that it's specified by the device type. And somebody else had a Raspberry Pi 4B on a LAA, and it started running my tests on their LAA. Now, I had configured my LAA slightly different from the normal one, and the tests failed. And it was like, okay. So we need to make sure that the hardware we're running the tests on is as we expect it to be. So that meant targeting my specific LAA. This was done by a tag initially. The tag is now gone. I'm assuming the Lava team have changed something so that when you use the name of the LAA as a tag for targeting, then that just works automatically without needing a specific tag setup. Also, we need to create the disk image. This is not specific to using a Linaro Automation Appliance, but it had to be done. I had to do it, first of all, for when I was running the Raspberry Pi on my desk, but just one job that had to be done. The firmware files that are provided by Raspberry Pi can be downloaded from the link, change the release numbers to whichever you need at the time. You don't need all of those files that are contained in that compressed tar file. The second link will give you a better idea of which firmware files you need. They depend on which version of Raspberry Pi you're using. You also need a config.txt. This is a very stripped down config.txt just for the Raspberry Pi 4B. The important line is the one right at the top where we say kernel equals uboot.bin, which is how we get the Raspberry Pi to run uboot, because that's not a standard configuration for it. This is using Guestfish to create the disk image, which lets you do it without needing sudo or anything like that. You can see here at the bottom, we've got the config.txt we just put in. We've got the uboot binary. And then these are the 4 firmware files from Raspberry Pi that needed to make the Raspberry Pi 4B boot. If you're using a different Raspberry Pi, there'll be a different list of files there. As I said, there are secrets used as API tokens that are passed around. So the Lava job was downloading from the GitLab artifacts, but the GitLab repo was not a public one, so I had to provide the GitLab private is a API token. It took a little while to find the correct syntax to make this work, but working with the Lava team, who are very helpful, and we got there. Next thing was I was using the default Docker container for uboot for testing, which has a default user of uboot. This is not how Lava expects their Docker containers to be. It's built assuming the default user will be root. So then had to rebuild the Docker container, change the default user so that we had a default user of root. Then the scripts can change user back to being uboot once you get into the script. Again, we need to pass more information into the container. Again, we need to get back to that private GitLab repo. So again, there's passing in secrets. Different syntax again, but we're passing GitLab API tokens into the Docker container. And yeah, we've got information that was created by the GitLab CI job and then written into the Lava job when it wrote it out. So from inside the container, which is a generic uboot container, it knows nothing about the Lava Automation Appliance. As Lava launches the Docker test shell, it produces these environment variables which tell us what the device type in the Lava definition, the device dictionary. So these are passed into the Docker container, and then these can be used to control power and reset, etc. for the device under test. Again, I had to work with the Lava team to actually get this to work properly. First of all, the environment variables weren't even passed in. Secondly, the overlay with the executables was not initially present. But again, they worked with us, and we got it sorted. It was very nice working on the staging version of Lava. We could get updates the next day. Hopefully, as I've gone through this work, it will be in the release very soon, and you won't have to go through all this pain. So we got that sorted out. The next thing was the host name of the container. The U-boot test hooks have to be on the path, and they assume that you know enough about the system that so that you're not confusing your test hooks with somebody else. They use the host name of the system in the path. This wasn't going to work with the Docker container because that's created dynamically, and you had no prior knowledge of what it would be. So we have the scripts that run on the Docker container, use a dummy host name that is then linked to the real host name. Then we had the console access to the device. So the console is running from Certinet. This is running on the Linaro Automation Appliance host. You're running in a Docker container. You need to connect to the Certinet, so that you've got your console access. A few issues here. Localhost is not the place where you need to be connecting to Certinet. That's the Lava host. Again, working with the Lava team. Told me to replace that with Lava Worker Internal, but again, took a couple of goes so that we got this resolved. And just working, I was working with the Ledge team with their proof of concept, and resolution of Lava Worker had not actually got into the release of Lava they were using. So that's coming soon, I hope. You can just hard code the IP address because it's a well-known host end of the Docker virtual network, but better if you use a name just in case anything ever changes in the future. And then one of the hardest things to actually get working was, I mentioned earlier that we built Hello World.AFI, which was used in U-boot in one of the tests from TFTP. There is a TFTP deploy action in Lava, and attempting to use that, put the Hello World.AFI in a path that had an unguessable section of it, and this information was not passed into the Docker container, which meant that we could not access the TFTP files that we needed. So the solution was use the downloads deploy action instead. And these files end up both accessible from TFTP and HTTP as well. And it's predictable path. So that was, took a little while to get sorted out, but when we did, that all works very well. So yeah, if you have files that need to be served up for testing from TFTP or HTTP, then your downloads deploy action is where they need to go. The little wrinkle here is this name here, GitLab files. will appear in the path when it's an archive that's extracted. So just watch out for that one. And that was about it. After that, I can test U-boot. I can make changes. They will all get built. They get put in a disk image. I may have skipped over this bit, but yeah, that disk image then goes onto the Linaro Automation Appliance, which is served up as USB gadget onto the Raspberry Pi 4B. So there is no writing to SD cards and wearing your SD cards out in 6 months or whatever. So this should be a usable and maintainable system for testing actual hardware. And I am very grateful to the Lava team and the people who designed the Linaro Automation Appliance, because it's a wonderful piece of kit. And I hope you'll all be going out and getting one and using it as soon as you can. Any questions? Hello. Thank you indeed. Anybody else? Nearly time for lunch.